Good morning, everyone. So I'm Felipe Medeiros. I work on the Endtoend automation team here at Facebook London. Sorry, this should have not started, but it's okay. So basically, I work on the Endtoend automation team, and we want to make sure we build the platform and infrastructure to run end-to-end tests at Facebook. So basically, imagine that one day you have a task, and then to complete this task, you need to execute some commands on your terminal. So you execute those commands, you finish your task, and that happens again on this next day, the next day, and that keeps happening. So as engineers, we love saving time, right? So what we'd probably do is just write a script, and the next time it happens to you, you would just execute the script and save your time. So when we think about DevTools, it's not only about making your life easier, but how can you make the life of everyone in the company easier? So if you work on a mobile company, the chances are that someone in that company will need to write a script that requires a device or an emulator. And even if you are outside of this mobile company world, your company might host a website. And on the website, you probably want to write a script that's going to actually require a browser. So if we think about browsers, devices, emulators, they're just resources. And on this talk, I'm going to talk about how we can manage resources at scale. So the brand new system that we built on Facebook is called OneWord, and this talk is going to be divided in 3 parts. First, I'm going to talk about what's OneWord, and after that, I'll take a look into the architecture of the system and the unique challenge that we face at Facebook scale. And given that you have such a system like OneWord that allows you to remote control resources, how can you use a system like this to actually improve the reliability of other services? So what's OneWord? So we can summarize OneWord as a service that allows you to remote control resources. So let's imagine that 5 years ago, Facebook was just celebrating 1 billion people using Facebook every month. But today, almost 2 billion people use Facebook. And we grew so much that we're not just a website company anymore. We actually have a family of applications. And as we grow, we also increase the technical challenge we face. We want to make sure we have first-class apps to everyone using our service. So at Facebook scale, that means we need to test hundreds of different scenarios across numerous types of devices and operating systems. And that we do both for correctness and speed. So that gives us another problem, right? Facebook's motto is about moving fast and breaking things. But even though we're growing so much, how we can make sure engineers are still coding super fast. So to give you some perspective about our growth, let's take a look at the number of WebDriver tests that we have at Facebook. So basically, we have way more tests today than we have 5 years ago. And this growth is basically because we started to hire more engineers. More engineers, they start to write more code. And as we write more code, we also write more tests. And the cool thing about this graph is like even though we have way more tests today than we had 5 years ago, we actually run them faster and more reliable. And that wouldn't be possible without a service like OneWord. So if we think about engineers, end-to-end, performance and tests, and other applications, at some point, they might need to use a resource. And then if we think about resources like devices, browsers, and even other remote resource that you want to control, and then if you put all of them together, and then you make just a single API that all your clients can request any kind of those resources, that's how we get OneWord. And to talk more about the scale that we're talking about at Facebook, this is a picture of our device lab. So we have devices in our data centers, thousands, and we are able to control those devices by using OneWord. So given that we have a resource management system, let's take a look into the architecture, how we build a system like this. So basically, OneWord could be divided in 3 main components. I'm going to go in deeper details on each one of them. But first of all, let's take an overview how actually everything works together. So we have a client, and this client wants to use a resource. So on the same host, on the same machine that the client's using, it will start a OneWord daemon. The OneWord daemon will talk with Jupyter, which is a matchmaking service. And the runtime worker service is the one that's responsible to manage our resources. So it's basically going to guarantee that our resources are healthy. And the runtime worker service will talk back with Jupyter and make sure it will get paired up with our client. So that after all of that is completed, our clients can finally use the resource. So first of all, let's take a look into the one-word daemon, how actually it works. So the client's on their machine, and they want to use a resource. So they will start a one-word daemon, and they start a session. So by session, we mean, for example, we want to use 20 iPhone 7. So after that's created, the one-word daemon will enqueue all those jobs into Jupyter, and the runtime worker service will constantly talk to Jupyter and get paired up together. So what's Jupyter? So as I mentioned before, Jupyter is a matchmaking service, and will basically guarantee that if a client wants to use an iPhone 7, it will get paired up with a runtime worker service that can give you an iPhone 7. So Adriana, just after lunch, is going to go in deeper detail how Jupyter works and how it changed Facebook's infrastructure. So let's take a look into the worker service. So the worker service is the one that's going to be responsible to manage the resources. And each host at Facebook can actually manage multiple of the runtime worker service. And we make sure to isolate them from each other. So given those runtime worker services that are isolated from each other, let's take a look into the life cycle of one of those. So before giving a resource to one of our clients, we need to make sure we do some sort of initial setup. For emulators and browsers, we want to make sure that resource is booted and is actually able to be controlled remotely. For devices, we have some unique challenges. We might want to unlock the device, disable the lock screen, and even change some system settings. But now that given that you have a resource that you can control them remotely, we also need to perform some health checks. If a client wants to use one of our resources, we want to make sure that resource is ready. And basically, these health checks depend on the type of the resource that we're talking about. If we talk about devices, they are really hard to do some health checks. Some of the health checks on devices, we might need a technician to go to our data centers and actually repair the phone or remove from our fleet. Other health checks on devices can actually be solved by simple just charging again the phone. And when we talk about browsers and emulators, those health checks could be as simple as a check and we have enough space on the SD card, and that's accessible to remotely. So now we have a ready resource, and it's healthy as well. So basically, the runtime worker service will now just talk to Jupyter and make sure it will get paired up with a client. So given now that we found one of our clients, one of the next steps that we can do is actually to execute commands that the client asks us to do locally. Suppose you are actually scripting something and you need to use hundreds or thousands of resources. And one of the things that you want to do on those resources is to install an application. So instead of doing that remotely, why you don't ask the runtime worker service to execute that locally for you? So that's going to save you some network time. So we actually also allow our clients to execute commands using the remote worker service. Okay, now given that you just finished to execute those commands, that the client just asked you to do it, so the next step of the runtime worker service is just wait for that resource to be released. So basically, when the client doesn't want to use that resource anymore, it will just talk with the one-word daemon and release that resource. And if the client's not using that resource anymore, our job's not finished here. We still want to make sure we're going to collect a lot of metrics and videos and logs for that resource. Suppose you are using one of those resources on the background and your job has failed. You probably want to understand why. So we want to make sure we're going to give you the video, we're going to video the logs. And all of that, we just send to our central databases, and we allow our clients to control them later. And another interesting part about OneWord is after we use a resource, we're actually going to restore the state. If we were just finished using a device, we want to make sure another engineer is able to use that device as well. For resources like browsers and emulators, this could be just as simple as booting again from the image. But we cannot do that for devices. Re-image a device is time intensive and actually adds wear to the internal flash storage of the device. So what we actually can do here is actually reset the phone, so we can reset the kernel settings, we can wipe data partitions, uninstall applications, and change back some system settings. So the goal here is to make sure the resource can be used by someone else later. So let's take a look again how the workflow of OneWord works. So the client, we will start the OneWord daemon and start a session. So the OneWord daemon, we will enqueue all those jobs to Jupyter, and the runtime worker service will keep health checking our resources and talking back to Jupyter to make sure they'll get both paired up. And at Facebook, we also have one thing called satellites. So basically imagine that you're an engineer and you have a problem with your phone. And to debug that problem, you need the help of your coworker. But at that day, your coworker decides to work from home. So you're not on the same physical location. So what are you going to do here? You're going to wait for one day to solve the problem. So at Facebook, we allow you to connect your devices to a network using OneWord, which will start a runtime worker service, which will help check that device. And the other engineer can now connect to the OneWord daemon and get connected to that device. So basically, we will allow you to remote add your devices. But how does the remote control actually work? So the remote control depends on the type of the resource that we're talking about. For browsers, it could be just as simple as starting a standalone server, so you can control them remotely. For emulators, it could be just as simple as exposing a DB over the network. And for iOS, for example, we open source a project called Facebook Simulator Control. And bear in mind, the name is super hard because simulator control can also control devices. So we use Facebook Simulator Control to control devices using for iOS. So this is basically an overview how actually OneWord works. But the important thing is not just to build a system like this, but how can we improve the reliability of other services? So let's take a look how can we use OneWord at Facebook. So basically, one of the main customers of OneWord is the Endtoend test. So every day at Facebook, we have hundreds of code changes. And those code changes can break our applications, and that's going to give a bad experience to our people. So end-to-end tests, we run several tests on different scenarios every day. So how can we make this better? So let's take a look on how we can actually use OneWord for end-to-end. I will assume not everyone here is familiar with the life cycle of a test run for an end-to-end test application. So in this example, I'll take a look of how it works on an emulator, but the same concept could be applied for a browser, for a device, for a simulator, or for anything else. So when we are talking about end-to-end testing, we also want to make sure that after we finish running a test A, the result of test A is not going to impact the result of test B. Suppose you just ran a test on an emulator, and that changed the user data. That user data later on can impact the result of test B. So one of the first things that we need to do is actually erase anything that's on the emulator. After we did that, we can finally boot a resource. And after we boot it, just remember that we just wiped everything. So we need to install the application again. So now, finally, we can actually run our test. And as I've mentioned before, it's really important to actually provide signal for engineers so they can debug problems later. So after we finish running the test A, we can actually shut down the emulator, upload videos and logs to our central databases, and allow engineers to use them later. So it's pretty clear that waiting on the emulator slows down the test runs. Before running test A, we had to waste a lot of time erasing, boot, installing, and shut down. So although this example is far from reality, we're just running one test here, and at Facebook we invest a lot on testing. So what happens if we need to run multiple tests? So a naive approach here would be just to run everything sequentially. So we start running test A, and then we move on to the second test. So we run test B, and then now we need to run a third test, right? So what's going to happen? Engineers now start to complain that the test run is slow. So instead of making their life easier, that we're providing enough signal that their code change is safe, we're now slowing them down. So, but you're right, we're probably going to repeat the same process over and over again. So okay, so how can we actually make this better? So we can actually run everything in parallel, right? So while we're running test A, we can run test B, and at the same time we run test C. So this looks perfect, but bear in mind that whenever you're erasing something or installing something, you might be doing operations on disk. And then if you're running multiple of them in parallel, when you're trying to erase something from the disk might not be on the correct location. So now you're waiting for your disk to spin. So those are I/O-bounded tasks. As many as you have more than, that's going to get worse and worse. And booting is a CPU-intensive task as well. So if you have too many boot operations, the CPU will start to get hammered, and it will leave less time slices for other processes. So this actually is going to add some load factor. And also it's important to notice that not every step is going to take the same duration. So while you're running test A, you can actually be installing the application to run test B. So basically it means you are actually having I/O-bounded tasks while you're running your test. So there's a big problem here, right? Before you're running test A, we had to erase, boot, install, and we also wasted time shutting down the emulator. So how can we make this better? So at Facebook, we decided to make this better by using one word. So let's take a look how one word changed end-to-end testing. So now imagine that you have a test host. And the test host, the main responsibility is to drive the test. So one of the first steps that the test host needs to do is to boot the application, to build the application we want to test. And at the same time, on other different set of machines, we have the one-word service that at the same time is booting the emulators. So if you remember one of the first slides, this is basically the setup step. So we are basically set up now for remote resource. So when we decided to run tests 1, 2, and 3, so the test host, we actually talk with the one-word daemon and control the emulators that are on the cloud. So those first 3 emulators that are on the one-word service will be controlled by these 3 tests. And when we decided to move on to tests 4, 5, and 6, instead of waiting for those 3 emulators to get ready again, we're just going to get 3 emulators from the cloud, different emulators. And you remember that we also want to make sure that our engineers have access to videos and logs. So basically, the upload step is now happening at the same time that we are already running the next 3 tests. We're not wasting your time here to boot or to install the emulators before running the test. We just focus on running the tests. And as I mentioned before, one word also makes sure to restore the state of the resource. So the 3 emulators that we've just used, they're going to be booted again. So whenever another client decides to use a resource like an emulator, we will just be able to use them again. So this example looks pretty simple because every test has about the same time of duration. None of the resources has failed the health checks. So let's take a look into another example where the test 1 is slightly faster. So we decided to run the first 2 tests using the first 2 emulators. And as I mentioned, sometimes your resource is going to fail to set up, and you just need to try again. Basically, when you're deciding to run test 3, the 3rd emulator could have failed. So what's going to happen to your test run? Is it going to get slower because you don't have a resource? Basically, one word will make sure to pair it up with another resource. So your test run is not going to fail because the emulator has failed to boot. And this emulator that has just failed to boot, we're going to try to make it happen again. So whenever a test 4 decides to be run, that test 4 can now control this resource that has previously failed to set up. So basically, when you decided to run test 5, 6, they're just going to control another emulators on the cloud. And the upload and boot emulator steps, they are happening on different machines. To give you some notion about the impact that we had on end-to-end tests, let's take a look on this graph. So the orange line represents the number of tests that we have for Android at Facebook. And the blue one represents the duration. So at some point, we added a lot of tests at Facebook, and at the same point, our duration of the test runs increased a lot. So basically, our infrastructure couldn't keep up with our growth. But then, we decided to ship OneWord. And as you can see, once we launch OneWord, our test runs become faster and actually more reliable as well. And today, to complete those test runs, we use less servers than we used to use before, because now every service has its own responsibility. So basically, OneWord gives a lot of stability for end-to-end tests. We're never giving bad emulator to the tests. And if you ever work with end-to-end tests, you know first you need to build the application, and after that you need to build the tests. So while you're building the tests, you can start installing the application on our emulators on the cloud. So actually you can save some seconds there as well. And as a result that we never give bad emulators to our tests, the test will never fail due to emulator flakiness. But one word is not being used only by end-to-end testing. For example, we have a team at Facebook called CT Scan. There is a blog post about it. So the main goal of CT Scan is to make sure our applications are fast. So CT Scan is to focus on performance testing. But they also had on previously to manage those devices. But now the CT Scan team can actually focus on the performance testing itself and let the one-word team manage those devices. Another team that we have at Facebook is called Sapiens. So Sapiens is a multi-objective end-to-end testing team. So we basically just try to automatically find crashes on the app using a short test path. So the Sapiens team can actually focus on improving the algorithm itself rather than manage emulators. They just let the one-word daemon do that for them. Another big use case of one-word is engineers. But why is one-word good for engineers? Let's take a look. So let's take a look for one word for engineers. So imagine that you were working at Facebook 5 years ago. So you probably had a phone that was plugged into your computer, and you could use that phone to debug any kind of problem that came to your desk. But as Facebook grows, we have more people using Facebook, we have more operating systems out there, and we have more different types of devices. So now Facebook needs to provide all those resources to every employee, because we want to make sure every employee has access to the same resources. But that will probably not scale, right? We cannot plug in all the devices into everyone's computer. So the solution here is to use actually the cloud. So basically the engineers can just connect to the remote resources by using one word. If they want to use a specific device, they can just ask one word for that. Let's take a look on how simple it is for an engineer to request an emulator. So basically, an engineer just needs to type one word ADB, and we just ask for emulator of the type Android 17. So after a few seconds, we are actually able to control those resources remotely, and then the engineers can just interact with the shell. So basically, one word was built to be a single API. It doesn't matter the resource that you're using. We want to make sure you can just request them with the same API. It doesn't matter if it's a device, an emulator, simulator, browser, or anything else. So we've grown to have more than 20,000 resources. And then we actually execute more than 1 million jobs per day. But this looks great, but what's next for one word? We're still working a lot to make that better. So basically, whenever engineers are debugging problems, they sometimes are platform specific. So sometimes the bugs that you're trying to face, cannot be solved just using a remote protocol like ADB. So we're actually building a live stream service that will allow engineers with just a click of the browser to connect with any device that's on our cloud and remote control them. So basically, if you want to test something on a very specific device, you just need to access our internal tools and have access to them in a few seconds. We also work on remote profiling. So basically, every code change at Facebook can have some impact of the performance of applications. And sometimes it's really hard for engineers to know all the possible outcomes. We have a lot of different devices out there. So basically, the remote profiling will make sure to run those tests on all of the devices on the cloud and report back to those engineers in a quickly possible time to make sure engineers are not wasting time. And there's much, much more to come for one word. So feel free to reach me out during lunch on the happy hour. And we also launched a blog post today. And feel free to check it out on code.facebook.com. We're just talking about one word and the other teams that are using there. Cool. Thank you.